Yeah.
Without blinking.
Oh, it's very small on my screen.
Well, you can see it right here.
Yeah.
It's pretty nice
Yeah.
size
Yeah.
there, and they point that
Okay.
out to everybody. We all know what to look for.
That's all right. I'll forget it anyway. Okay. This is the last one. And this one, if I recall, talks about test equipment and soldering and a multimeter. Everybody should have a multimeter. Just
because you're
Just because-
alive and there's electricity stuff in your house.
right. Has nothing to do with amateur radio. It's the most common piece of test equipment. You can pick them up. You can get little cheap ones at Harbor Freight sometimes for free, just for buying something,
I like free.
or buy one for $2 or $3, something like that. I mean, they're just basic, like 3 function. But depending on what you're doing, I've got a few of them. And sometimes you can use them to, maybe hook up some little test circuit and you put a couple of them in there to measure voltages and currents all at the same time.
I have an expensive one, a Fluke, but it didn't test for amps. So I found out recently that when you buy cheap batteries,
Yeah,
their quality control is horrible. Because one battery, you might get a good one, and the other one is garbage. And so I had to buy a amp tester. So I didn't want to buy another expensive one. I bought a cheaper one, which I can test up to, I think, 10 amps or something like that. And now I test my batteries when I buy them. I test them and make sure that it does what it says. Or I'll send it back and say, that battery does not mean what you sold it to me as.
okay, normally a multimeter will have at least a voltmeter function, an ohmmeter function, and an ammeter function. Most of them you get nowadays will measure temperature, capacitance, both AC and DC voltages, check diodes, measure gain on transistors, all kinds of extra functions. So when it's in the voltmeter setting, okay, it's going to measure the electrical potential in volts. When it's in the ohmmeter setting, it's going to measure resistance in ohms. And when it's in the ammeter setting, it's going to measure out your current in amperes. I should say on the voltmeter setting, it will be measuring DC volts. If it's measuring AC, depending on how good the meter is, it may be measuring RMS voltage correctly, or it may not. You usually have to pay more for a multimeter that is a true RMS reading meter. And particularly if it's not a nice pure sine wave, it's definitely not going to read correctly. One of the biggest mistakes where you need to go buy a new one is if you're going to measure 120 volts AC and you got it set to measure resistance. You probably only get to do that once, and then you no longer read resistance. Here's a couple. Simpsons. This is the old standby analog type. They're still good for some things because you can actually see the needle move for varying signals. These occasionally I see them at the ham fests. Quite expensive, a couple $100.
They're probably accurate.
This is the new version. It's also a Simpson, okay, and they're a couple $100.
I just bought like a $30 one just recently.
A Simpson?
No,
Oh.
it was a no,
Yeah.
some cheaper one. I
Yeah.
just needed to be able to measure batteries.
I don't know if it's that much better and worth that kind of money, but yeah. And you can see on there, you know, it's got AC volts and I can't read that.
Says 1 MO. I don't know what that.
Oh, mega ohm.
Okay.
And DC volts is that double signal, millivolts. A lot of them don't go down into the millivolt range. They've got ohms to measure diodes, temperature, capacitance, milliamps, amps. Even dB of some sort, frequency, all kinds of stuff. Which of the following measurements are made using a multimeter? Of the choices there.
Definitely.
I would say Charlie.
Charlie. Yeah.
Yeah.
We'll go with Charlie. Which of the following can damage a multimeter?
C. Oh, wait.
See.
You changing your mind?
I was like, wait, did I just read it too fast? No, I just want to make sure.
Yeah, on an exam, read them carefully.
Yeah.
Measuring voltage on the resistance setting. If you're trying to measure resistance on the voltage setting, it's not going to hurt the meter. Okay. When we have a separate voltmeter, and these are kind of rare nowadays, mostly laboratory type instruments where it's very high precision. But its function is to measure the electric potential across 2 points. And you connect them in parallel. Same thing with a multimeter. It may have some very low, millivolt or even lower settings up to some, maybe a few thousand volts. Could have an analog or a digital display. There's still a lot of analog meters around. Will normally always be in volts. And they normally have a very high resistance, so they don't affect or have much effect on the circuit when you connect them in parallel to something. It'll appear to be many, many mega ohms of internal resistance. And you also need to make sure that if you're going to measure 240 volts out of a wall socket, that your voltmeter's rated for that voltage range. And usually even the cheaper ones will go up to like 700 volts on AC, and I think the same on DC. If you're going to use it inside of a tube power amplifier that might have as much as 3,000 volts on the plates, then you need to make sure you had one rated for that. And most of the cheaper ones wouldn't go that high. Also, your test leads probably wouldn't be good for that kind of voltage rating. They'd probably arc over. Which instrument would you use to measure electric potential?
Voltmeter.
Bravo.
Okay. How is a voltmeter connected to a component to measure applied voltage?
B in parallel.
Bravo.
Yep. Since a voltmeter has an extremely high input impedance, if you put it in series, it'd just be like opening the circuit. Which of the following precautions should be taken when measuring high voltages with a voltmeter?
B. Otherwise you'll blow it out.
Okay, ohm meters. Again, you don't normally see these as separate instruments. If you do, it's probably something like a Wheatstone bridge, which is used for very accurate resistance measurements, like laboratory type stuff. But it's used to measure resistance by, in most cases, they supply a known current to the circuit. And it actually measures the voltage drop due to that constant current. So it's only indirectly measuring resistance. It's measuring the voltage with the known current, and therefore with Ohm's law, you know what the resistance is. And that's what it calculates if it's a digital display. If it's analog, the scale is designed so that it's doing that Ohm's law calculation for you. Okay, it's always going to display in ohms. If you go to measure something and it initially looks like it's 0 ohms, and you notice that the reading starts increasing, it's easier to see with the analog type where you see the needle certainly, climb up to some final point where it sits there, usually a very high resistance. That's normally the indication that you're measuring across a fairly large capacitor, and you're seeing a capacitor charge up from the current being supplied by the ohm meter. So you'll see it increase until it charges the capacitor, and then it'll just look like a very, very high resistance. You see the opposite if you're looking across a very large inductor. It's initially going to have a high resistance, and it will decay down to almost 0, usually fairly quick, unless it's a very, very large inductor.
I'm gonna need a trick to remember that.
And you also want to make sure that when you're measuring resistance, you don't want to have any power on the circuit, because that's like measuring voltage with it in resistance, even though you didn't intend to be measuring voltage. So it'll probably damage the meter. So how is an ohm meter connected to a component to measure its resistance?
In series.
Bravo.
Yeah, B.
We have a range here. Say, who said alpha? Who said Bravo?
Me.
I did.
Who said Charlie? Anybody say Delta?
Really? Oh, okay.
The only one that you do, I shouldn't tell you this here because it's coming up next. The only one you do in series is an ammeter.
Okay.
So which of the following precautions should be taken when measuring in-circuit resistance with an ohm meter?
No power. Where's that? Yeah, B, no power.
All right.
Was I too fast again? I'm sorry.
What reading indicates that an ohmmeter is connected across a large discharged capacitor?
Okay.
Very good. Ammeters. Now, you may find separate ammeters, particularly ones that measure AC current, where it's a clamp-on type, as a separate instrument. But usually for all these things, you're going to use your multimeter. So it's used to measure current in a circuit. The reason it's in a circuit is it's in series. So as an ammeter, okay, it appears to have a very low internal resistance. So you're not going to affect the circuit very much. Can have an analog or digital display. It's going to display its output in amperes. And once again, you need to make sure that it's rated for the current you're going to measure. Most of the multimeters measure like up to 10 amps, and they may have a separate jack where you connect it to maybe measure 20 amps. If you're going to measure something beyond that, then you need a different ammeter.
Up to 10, and there's a fuse inside. That's a good part. We immediately to see it. I haven't seen it. It's definitely a fuse because you have to move the jack over anyway, just for amps.
So what instrument is used to measure electric current?
And
Yeah, I don't know why they leave the P out.
It's not saying it's delta, but it's
Delta.
looks different.
Mhm.
Oh. When configured to measure current, how is a multimeter or an ammeter connected to a component?
the only one that goes in series.
Alpha.
Would be easy to remember now.
Okay, good. In series. Okay, soldering. Now, they claim it's an essential skill. You may or may not ever solder. It depends on what your interest is. If you're into building stuff or trying to repair stuff, then you might want to learn how to solder. When you're doing electronic circuits, you need to use what we call rosin core solder. It's actually well, I was going to say a tin lead compound, but now there's non-lead solder. Doesn't work very well. And it's hollow, and it has what we call flux, which is made out of some kind of rosin that will, when you heat it up in order to solder, it actually cleans the surfaces so you get a better contact, and it makes the solder flow better. There's another type that you use in plumbing and things like that called acid core. That's not very compatible with electronic circuit boards and things. So you definitely don't want to use acid core solder on a circuit board. You need to make sure that you heat the components up, and usually you're connecting two things. So you want to try to heat the wire and what it's attached to at the same time. And then make sure that it's hot enough that you actually see the solder flow. It'll start to melt and kind of make a blob, but with more heat, it will actually flow, and you'll see instead of a blob, you get more of a teardrop type shape on it. After you've done it a few times, you can definitely see the difference. It's easy to tell when it flows. If it's a really good joint, the solder will be really bright and shiny, nice smooth surface, and it'll look like silver. If it's a bad joint, it's gonna be, might be kind of grainy, it's gonna be a dull color. They say lumpy, usually it's gonna look like it's just a round blob or ball because it hasn't been hot enough to flow. Or the components you're trying to solder have oxide or something, so it's not it's dirty, it's can't make a good connection. And you can usually tell the difference just looking at it without having to measure it. If you do have one of those and you measured it with an ohm meter, you'd see a high resistance. And usually if they're really grainy, if you put much pressure on it, they tend to break. Which of the following types of solder should not be used for radio and electronic applications?
Acid core.
A, alpha.
Okay. What is the characteristic appearance of a cold tin lead solder joint?
Rough or lumpy? No, bright or shiny, because
Yeah, bravo.
the tin lead is the good one, bright or shiny.
No, we want a bad joint.
Okay,
Oh.
so,
C.
okay, so you mean after the, or while you're doing it, not after the fact?
Well, after
Because after the fact, it's all gonna be cold.
well, okay.
Because if
I don't
it's
think
while
cold,
you're
I
doing
don't think
it,
cold is the best word there.
right?
Um,
It's like if you're, are you saying like while you're making it? Or if you're looking after it's all done and you're inspecting it? Because if it's while you're making it, then it would be really hot and shiny.
Yeah.
But if it's after, it's all gonna be cold.
Okay, I agree. The question, which is not mine, is confusing.
Yes.
And what they're referring to, when they say a cold joint, is implying that it wasn't heated hot enough when you made the joint.
Okay.
That's what we call a cold solder joint,
Oh, okay.
not the fact that it's cooled after the fact. But yeah, it is a little confusing if you've never heard it before.
No.
Yeah, so Charlie.
Yes.
Okay. So multimeters measure voltage, current, resistance, and you don't want to blow them up by measuring voltage when it's in the resistance setting, any of the resistance settings. Voltmeters measure potential in volts. You connect them in parallel. Make sure that they're rated for the voltage you're trying to measure. You connect ohm meters in parallel, ensuring the circuit you're measuring is not powered up. And if you see a increasing resistance, it indicates a charging capacitor. And ammeters measure electric current in amperes. And they're connected in series to do the measurement. That's the one that's different. For soldering, always use rosin core solder for electronic components. Make sure that you use enough heat to cause a good solder flow, but not too much heat, because you can overheat the components and cause damage. So once you get it solder to flow, then stop. It's a case where too much is not a good thing. Your finished joints, after they're cooled, should be nice and bright and shiny, silvery looking, smooth surface, kind of like a Hershey Kiss type of shape. If it's like a component coming through a circuit board, you'll see the little like teardrop things. If it's a blob, it's kind of dark colored, it's maybe a grainy surface. It means that it wasn't heated enough to actually flow, or the things you're trying to solder were corroded or tarnished, oxidized. Basically, you got a bad joint.